No. I did not get in the little plane at the little airport. I'm not gonna get in this flown by that guy that could fix our car.
This week in AI, the impossible is becoming possible. We've got an AI that can restore a hopelessly blurry photo into a crystal clear image, another that can edit a real photograph just by describing the change you want to see, a tool that transforms shaky, unusable video into buttery, smooth shots without cropping a single pixel, an AI that can perfectly clone a voice and its emotions for dubbing movies.
你就不怕报应？午夜梦回的时候，你就不怕纯元和孩子来向你追魂索命？
他要来索命，尽管来索呀！
Aren't you afraid of retribution? In the dead of night, aren't you scared that Chunyuan and the child will come for your soul?
If she wants my soul, just take it away!
And a jaw-dropping video editor from Adobe that gives you godlike control to add, remove, or change anything across multiple subjects and scenes. And we're going to cap it all off with a true underdog story, a brand new video model trained for just $500 that claims it can beat the $100,000 giants. Is it hype or is it the future? You are not going to want to miss a second of this. Let's get into it. All right, kicking things off with a tool that is seriously blurring the lines between an AI that can see and an AI that can create. It's called TAR, spelled T-A-R, which stands for Text-Aligned Representation, and it comes from the brilliant minds over at ByteDance. Now, we've seen models that are great at describing images, and we've seen models that are great at generating images from text. TAR is so exciting because it's designed to do both exceptionally well using a single unified framework. It's a true multimodal powerhouse that can both understand and generate visuals, and the results are pretty mind-blowing. First, let's look at its understanding capabilities. You can give it an image, and it doesn't just list the objects, it captures the entire mood. Take a look at this picture of a stone house with a flower-filled balcony. TAR's analysis? Fairy tale vibes. This stone house looks like it's straight out of a storybook. That's spot on. It's not just house, flowers, stone. It's capturing the feeling. Or check out this complex fantasy scene. It correctly identifies not just the forest and glowing moon, but 3 human figures are seen from behind observing a colossal green-haired creature. The level of detailed comprehension here is just next level. But that's only half the story. The generation side is where TAR really starts to flex. The team prompted it with 16-year-old redhead girl with many freckles, gray eyes, full lips. And the result is this stunningly realistic portrait that absolutely nails every single one of those details. Then they tried something more abstract, a Chinese rabbit made of white ceramic with blue ink, stunning intricate designs, geometric and floral patterns, fine art. And bam, it generates exactly that. You can see the ceramic texture in the beautiful blue ink patterns perfectly matching the prompt. But the one that really got me was this ridiculously detailed prompt for a photo of a cat. It described a ginger and white cat sitting in a sunlit grassy field, positioned slightly to the right, foreground features out-of-focus blades of grass, creating a dreamy bokeh effect. I mean, they are directing it like a professional photographer. And the image it produced is, well, perfect. So what's the secret sauce here? How does it do both so well? The core idea is to treat vision as just another dialect of language. When you give it an image to understand, a special component called a text-aligned tokenizer, or ATA talk, breaks the image down into discrete visual words. These visual words are then fed into a large language model, which reads them and outputs a description in plain text. For generation, the process is reversed. You feed it a text prompt, the same LLM thinks about it and generates the corresponding visual words, and then a detokenizer skillfully stitches those words back together into a high-fidelity image. The key innovation is using that same autoregressive LLM for both tasks, making the whole system incredibly efficient and elegant. And here is the best part for all the builders and tinkerers out there. TAR is open source. The team has released the code and the pre-trained models for everyone to use. They are built on top of the QN 2.5 model, and the GitHub page provides the instructions to get it all set up. Now, they offer 1.5 billion and 7 billion parameter models. While they don't list specific VRAM requirements, for a model of this size, especially the 7B version, you're going to want a pretty beefy GPU. I'd estimate you'll need at least 16 gigabytes and probably 24 gigabytes of VRAM or more for comfortable and fast generation. As always, I'll have the links to the official project page and the GitHub repository down in the description so you can dive in and try it out for yourself. All right, for our next tool, we're diving into what many consider the next frontier of AI imaging, editing real photos with nothing but a text prompt. This is called ReFlex, and it's all about text-guided editing of real images with an insane level of precision and coherence. Forget just generating from scratch. This is about taking an existing photo and surgically altering it to match your imagination, and the results are something you have to see to believe. Let's start with some of the incredible examples. They take a photo of a man posing and give it the prompt a photo of an origami man. ReFlex perfectly transforms the man into a papercraft figure while keeping the exact same pose. Now prompt a photo of a grizzly bear jumping in front of the cabin, and the man is replaced by a massive grizzly bear in the same dynamic pose, and the background is seamlessly replaced. Or a photo of a silver robot in the snow. Again, the subject becomes a robot, the ground turns to snow, but the structure of the image, the pose, the lighting, it all stays remarkably consistent. It's a masterclass in understanding composition. This works with multiple subjects too. Here's a photo of a couple dancing. With the prompt, a photo of origami couple dancing in the kitchen, it swaps them for origami figures and changes the setting to a kitchen. It's also incredibly skilled at precise local editing. Here's an image of a woman reading a book. Simply change the prompt to a woman with a laptop, and the model replaces only the book, leaving everything else untouched. It also nails style transfer. Take a standard photo of a sports car and add the phrase stained glass window of to the prompt, and the entire image is transformed into a beautiful stained glass art style. So how does it pull this off without turning the image into a garbled mess? This is where it gets really interesting. This is a multi-step process that's incredibly clever. The entire model is built on top of a powerful state-of-the-art text-to-image framework called ReFlow, specifically using Flux 1. Unlike older diffusion models, ReFlow models are known for better image quality and text alignment. The first challenge is getting the source image into this model's language. ReFlex does this through a process called inversion, but with a critical twist. Instead of inverting the image all the way back to pure random noise, it stops at a mid-step latent. The researchers found that this midpoint blueprint preserves the structure of the original photo almost perfectly, which is something fully inverted latents struggle with. Once it has this high-quality structural blueprint, it begins generating the new image based on your text prompt. To ensure the new image follows the original structure, ReFlex identifies and extracts 3 key features from that mid-step latent: the image-to-image self-attention, which holds the core structure, the image-to-text cross-attention, which links parts of the image to words, and the residual feature, which contains other important visual information. It then injects these structural features into the generation process of the new image. This is what allows it to replace a bear with a dog in the exact same pose and style. For local edits, like changing a book to a laptop, it even generates an internal mask from the attention map of the word book to ensure only that specific region is altered. This is a training-free method, meaning it's not retrained for every image, it's a dynamic process that happens on the fly. And the team put it to the test against 9 other leading image editing models. And the results speak for themselves. In side-by-side comparisons on two different benchmarks, ReFlex consistently produced results that were closer to the text prompt while better preserving the original image's composition. In human evaluations, users preferred ReFlex's edits 68.2% of the time compared to other flux-based methods and 61.0% of the time against stable diffusion-based methods, which is a massive win. ReFlex is an open-source project, and the full code was recently released on their GitHub. As mentioned, the backbone model is Flux 1. Now, Flux is a significantly larger and more demanding model than Stable Diffusion. While the paper doesn't specify VRAM requirements, a model of this magnitude, especially for editing tasks, will be very demanding. I would estimate that you'll need a high-end GPU with at least 24 gigabytes of VRAM to run this effectively. This isn't a tool for your average gaming PC, but for those with the hardware, the results are state-of-the-art. I'll have the link to the project page, the research paper, and the GitHub repository for you down in the description so you can explore all the incredible examples for yourself.
All right, up next we have a tool that tackles one of the most time-consuming and frankly frustrating challenges in animation: long-form colorization. Anyone who's worked in animation knows that keeping colors perfectly consistent across hundreds or even thousands of frames is a massive manual effort. Existing AI tools often fail here, with colors drifting or flickering over time. But a new framework called LongAnimation is here to change the game, promising perfect long-term color consistency from just a single reference image. The core idea is simple but powerful. You provide the model with two things: a single, fully colored reference image of your character or scene, and your entire black and white line art animation. LongAnimation then gets to work meticulously applying the colors from your reference image across the entire video, no matter how long it is. Just look at this 27-second clip. The colors of the girl's dress, her hair, and the background leaves are perfectly consistent from start to finish, all guided by that one initial picture. It understands the context and applies it flawlessly. But it gets even better. The system is flexible enough for creative changes on the fly. Check out this example where they take the same animation but provide a different reference image, where the two girls have swapped shirt colors. LongAnimation doesn't get confused. It simply understands the new color reference and generates a brand new animation where the clothing colors are perfectly swapped throughout the entire sequence. It can also handle incredibly complex scenes. Here's a reference with a dozen different colors: green, red, purple, yellow, and the output video is a perfect match, correctly coloring every single element exactly as intended by the reference. So what is the revolutionary tech that makes this possible? The secret lies in what they call a dynamic global local memory paradigm. Previous methods only looked at a few overlapping frames at a time, which is why colors would eventually drift and forget what they were supposed to be. LongAnimation, however, has a nearly perfect memory. It uses a powerful submodel to analyze the entire history of the video it has generated so far, that's the global memory, as well as the most recent segment, the local memory. For every new frame it colors, it dynamically pulls the relevant color information from its entire memory, ensuring a character's shirt that was blue in frame 1 is the exact same blue in frame 500. This is all handled by a specialized transformer architecture they designed called SketchDit, which is built to expertly fuse the reference image, the text prompts, and the line art sketches together. And when you put it side by side with other state-of-the-art animation colorization tools like AnyDoc and LVCD, the difference is night and day. In the comparison videos, you can see competing models produce artifacts or fail to match key features like the character's eyes. LongAnimation, on the other hand, delivers a crisp, accurate, and stable result that is miles ahead. The numbers back it up too. It improves video quality and consistency metrics by a staggering 49% over previous methods on long-term animation tasks. Now, for all you animators and developers wanting to get your hands on this, the team has open-sourced the entire project. The code is available right now on GitHub under an Apache 2.0 license with full instructions to get it running. This could be an absolute game changer. As always, I will have the links to the incredible project page and the GitHub repository down in the description for you to check out. Next up is a tool that genuinely feels like black magic for image editing and restoration. It's called Inverse FLAIR. And while you might think of it as just another image upscaler, it is so much more powerful than that. This is a state-of-the-art generative model designed for all kinds of image restoration tasks, from magically depixelating blurry images to filling in massive missing chunks of a photo as if they were never gone in the first place. Let's just jump straight into the results, because they are mind-boggling. First, take a look at its upscaling power. Here's an incredibly pixelated, zoomed-in image where you can barely make out any details. After running it through Inverse FLAIR, you get this: a sharp, detailed, and coherent image that looks like it was shot in high resolution. The model isn't just sharpening edges, it's intelligently generating the details that were completely lost. The same goes for this photo of a child. The original is low-res, but the upscaled version is breathtakingly sharp. But the real showstopper is its in-painting capability. Look at this image of a lion, where the creators have deliberately covered up several large sections. After Inverse FLAIR works its magic, this is the result. It has perfectly reconstructed the missing parts of the lion's face and the mane. What's incredible is how seamlessly it blends the generated parts. It doesn't even look AI-generated, it just looks like the original, pristine photograph. It truly understands the texture, the lighting, and structure of the image. This model also absolutely smokes its competitors. When you compare its output to other methods like FlowDPS, the results from Inverse FLAIR are consistently cleaner, more detailed, and free of the strange artifacts that can plague other models. But here's where it goes from a great restoration tool to an incredibly creative one. Inverse FLAIR can also perform conditional editing. For example, the researchers took this photo of a man, covered his eyes, and gave it the simple prompt, "man wearing aviator glasses." And bam, it generates a perfect pair of aviator glasses that fit his face naturally. They did the same thing by covering his head and prompting "man wearing a wizard hat," and it created a hat from scratch. My favorite example is when they covered his eye and prompted "man with Mike Tyson facial tattoo," and it generated the iconic tattoo on his face flawlessly. It can also generate clown makeup, completely changing the person's appearance based on the prompt. This shows the model isn't just filling in blanks, it's understanding your text command and intelligently merging it with the existing photo. So how does all this work? The magic is rooted in its advanced architecture. Inverse FLAIR is a flow-based model that uses a technique called variational posterior sampling. In simple terms, instead of just making a rough guess at the missing pixels, it learns a smooth, reversible path from pure noise to a clean image. For restoration, it runs this process in reverse. It looks at your corrupted or low-res image and calculates the most probable path it could have come from, effectively reconstructing the clean original. The FLAIR part of its name stands for Flow-Based Latent Alignment for Image Restoration. And this alignment in the model's internal latent space is the key to its stunningly high quality and artifact-free results. And for all the developers and tech enthusiasts out there, here's the best part. The code is fully open source and available on GitHub. The page includes all the instructions you need to install it and get started. Now, the documentation doesn't list specific hardware requirements, but a state-of-the-art generative model like this is going to be demanding. As always, I will leave the link to their incredible project page and GitHub repository right down in the description for you to explore. Okay, get ready for a tool that might just completely revolutionize the dubbing industry and text-to-speech as we know it. This is Index-TTS 2, and it represents a massive breakthrough in creating emotionally expressive and controllable AI voices. This isn't just about converting text to audio. This is about capturing and transferring the very soul and emotion of a performance. This incredible project comes from the research team at Bilibili, the company basically the YouTube of China. The standout feature here, without a doubt, is its jaw-dropping talent for dubbing. It listens to the original actor's performance and mirrors the exact emotion in the new language. Let's start with this first clip from a Chinese film dubbed in English using Index-TTS 2. Pay close attention to the emotion in the voice.
臣妾多想恨你啊！可是臣妾做不到啊！
Do your majesty think I don't want to? I wish I could hate you.
But I can't. But I really can't do it!
How cool is that? Here's another clip from a Chinese film.
这对玉镯，还是臣妾入府的时候，皇上亲自为臣妾戴上的。燕如此环，朝夕相见。
Now listen to the same scene, dubbed into English by Index-TTS 2.
These jade bracelets were given to me, and your majesty put them on me personally. May this ring be a symbol of reunion, day and night.
It's stunning. The tone, the pacing, it's not just a translation, it's a full-on performance capture. Let's break it down further with another example, this time going back and forth. Here's the original Chinese dialogue.
臣妾要告发熹贵妃私通，秽乱后宫，罪不容诛。宫规森严，祺贵人不得信口雌黄。臣妾若有半句虚言，便将五雷轰顶，永不超生。
And now, the English version generated by the AI.
I report consort Ixi committing adultery, defiling the harem, a crime worthy of death.
The palace is strict. No false rumors, Lady Qi.
If I lie, may I be struck by lightning and never reincarnate.
Did you hear that? The emotion is a perfect match. It understands the feeling behind the words and replicates it flawlessly. But can it handle different emotions? Well, let's look at this much more aggressive and angry scene.
你就不怕报应？午夜梦回的时候，你就不怕纯元和孩子来向你追魂索命？
他要来索命，尽管来索呀！
You can hear the raw intensity in the original. Now check out the English dub.
Aren't you afraid of retribution? In the dead of night, aren't you scared that Chunyuan and the child will come for your soul?
If she wants my soul, just take it away!
The dubbed version is just as intense and powerful. It perfectly replicates that aggressive emotional state. This is what sets Index-TTS 2 apart. It's an emotional translator, not just a word translator, and the project page is filled with even more of these incredible comparisons. But that's not all. It's also a state-of-the-art zero-shot voice cloning model. This means you can give it a tiny 4-second audio sample of someone's voice, and it can then generate completely new sentences in that same voice. On their project page, they give this audio prompt as a sample.
It has traditionally been used for growth of human lymphocytes.
Now listen to the original target audio.
The equipment needed to do this includes rock saws and polishers.
And here is the clone generated by Index-TTS 2.
The equipment needed to do this includes rock saws and polishers.
It's a perfect clone of the voice. But here's where it gets even more interesting. You get fine-grained control over the audio's duration. They show how you can make the speaker talk faster or slower. Here's the clone at 0.75x speed.
The equipment needed to do this includes rock saws and polishers.
And here it is slowed down, stretched to 6 seconds.
The equipment needed to do this includes rock saws and polishers.
The voice stays completely natural and coherent, which is a huge plus for fitting dialogue to a specific video timeline. When you compare its output to other popular models like F5-TTS,
the equipment needed to do this includes rock saws and polishers.
You'll notice that F5-TTS can sound slightly robotic, while Index-TTS 2 sounds significantly more human and natural. Now, for the big question, can you use it? The project page with all of these mind-blowing demos is live, and I highly recommend you check it out. However, the code and model for Index-TTS 2 have not been made open source yet. The team at Bilibili has a history of releasing their work, with versions 1.0 and 1.5 being available, so it's very likely that this new, incredibly impressive version will be released to the public soon. Given its power, this is definitely one to keep a very close eye on. When it drops, it could be a complete game changer. As always, I'll have the link to the mind-blowing project page in the description so you can hear these incredible examples for yourself. Next up, we have a tool that tackles a problem every single person knows all too well: shaky footage. Video stabilization has been around for years, but it's always come with a frustrating trade-off. To get a smooth video, the software has to crop in, cutting off the edges of your shot. But what if you could have perfectly stable video without losing a single pixel? Well, buckle up, because a new method called GAVs is here to do just that, and it looks like absolute magic. Let's dive right into the demos, because seeing is believing. First up, look at this clip on the left of a woman walking through a park. The footage is super shaky, almost unusable. Now look at the right side, the output from GAVs. It's incredibly smooth, and most importantly, the frame is identical. Nothing is cropped out. Next, check out this example of someone walking over uneven rocks. The camera shake on the left is intense, but the GAVs version on the right makes it look like it was shot on a professional gimbal. Here's another one, a man walking downstairs. The original on the left is jarring and jerky. The stabilized version on the right is so fluid it looks like a planned cinematic shot. It completely preserves the original motion intent while removing all the unwanted jitter. So how does it pull off this seemingly impossible feat? This is where GAVs completely changes the game. Instead of thinking in 2D and just warping pixels, GAVs thinks in 3D. The paper reveals a revolutionary new approach where stabilization is reformulated as a local 3D reconstruction and rendering problem. To begin, and this is the secret to avoiding cropping, it uses a powerful video in-painting model to intelligently extrapolate or outpaint the video, creating extra content around the borders to work with. Then comes the core magic. For each frame of the video, it creates a temporary miniature 3D model of the scene using 3D Gaussian splatting. Once it has these local 3D scenes, it doesn't try to smooth the video itself. Instead, it calculates a new, perfectly smooth camera path. Finally, it just renders new, stable frames from the 3D reconstructions using that smoothed path. It's like building a tiny 3D movie set for every moment of your video and then refilming it with a perfectly steady hand. And when you put GAVs head-to-head with other stabilization methods, it's not even a fair fight. The project page shows some brutal side-by-side comparisons. 2D methods like Metastab and Pusa produce bizarre wobbly distortions and blur because they don't just understand the 3D geometry of the scene. Then you have Deep 3D. Now this one is stable, but look at the huge black bars. It has to crop the video so aggressively that you lose a massive chunk of your original shot, in one case even cutting the person's face completely out of the frame. GAVs suffers from none of these problems, and in a user study, participants preferred its output over 60% of the time. And what's more, it even gives you control over how stable you want the video to be. You can adjust the stabilization level, so if you want to keep a little of that handheld feel, you can. Or you can crank it up to level 8 for that perfectly locked down tripod-like smoothness. And the best news for all the creators and developers out there? The team has made the entire project open source. The code is up on their GitHub page right now with full instructions to get it running. Now, this is a sophisticated pipeline. The paper mentions they ran experiments on a single RTX 5000 GPU, so this is definitely aimed at a professional or high-end consumer with a powerful graphics card. But for anyone serious about video production, this could be an absolute game changer. As always, the links to the mind-blowing project page, the full research paper, and the GitHub repo will be waiting for you down in the description. Next up, we have an absolute monster of a tool that might just represent the future of creative video editing. It comes from a powerhouse collaboration, including Adobe Research and Johns Hopkins University. This is a full-blown, subject-driven video customization framework. That's a fancy way of saying you can give it an image of literally anything, a person, an animal, an object, and then take full control, telling it exactly what to do using text, other images, camera paths, and more. The level of control here is astounding. Let's start with single subject customization. You give it a reference photo of this woman, and the prompt is, the woman in image 1 is talking to a man on a street. And just like that, it generates a video of that exact woman with the same identity doing precisely what you asked. Or take this photo of a giraffe. The prompt is, the giraffe from image 1 is standing in the winter. And the output is a video of that specific giraffe in a snowy landscape. But that's just the warm-up. It gets really impressive when you start mixing subjects and styles. Here you have a reference image of 2 toy cars. The prompt is, a dog is playing with the yellow toy car from image 1 in a living room. And the result is a video of a dog playing with that exact car. It can even transfer abstract effects. They provide an image of some funky, colorful glasses. The prompt is, a girl is putting on a pair of glasses that turns into the effect of image 1. And watch this. As she puts on the glasses, they transform into that vibrant artistic effect. That's incredible. It's not just moving an object, it's transferring its entire aesthetic. OmniVCus is also a master video editor. You can give it a reference video and then use text to change it. For example, here's the yellow car again, but the prompt is, turn the color of the toy car to red. And in the video output, the car's now bright red. It can also do removal. Here's a man wearing a black coat. The prompt asks to remove the coat, and in the resulting video, poof, the coat is gone. It can also do replacement. They take an image of this boy and prompt it to swap the pea shirt of the boy with a blue shirt praying in a temple. And it generates a video of the boy in a blue shirt in a completely new setting. It can even change emotions. Here's a mother and child. The prompt says, make the child in image 1 happy doing her homework. And the generated video shows the little girl cheerfully doing her work. Okay, let's crank the complexity way up with multi-subject composition. Here we have 2 separate images, one of a man running and one of a church. The prompt is a man of image 1 running in front of the church of image 2. And the model flawlessly combines them into one coherent video. Or how about this? An image of a man with a wheelbarrow full of pumpkins, and a separate image of an orange. The prompt asks to replace the pumpkins with oranges, and the output shows the wheelbarrow now overflowing with oranges. It can even get as complex as taking 4 separate images, a person from one image, a laptop from another image, a coffee cup and a tomato from the 4th image, and a single prompt that asks to combine them all, and it does it. It generates a video featuring the person using that specific laptop with that cup and that tomato on the table. The composition ability is on another level. And if that wasn't enough, you can control it with more than just images. You can provide a specific camera trajectory. In this example, they give it an image of a woman, an image with flowers, and a looping camera path. The prompt is a woman from X standing by the flowers from Y, and the output video not only combines the subjects correctly, but has the camera perfectly follow the specified motion path. You can even generate dynamic 4D models. Just give it the prompt, a building on fire or a baby dragon hatching out of a stone egg, and it creates these incredible moving tableaus.
So what's the secret sauce? This is a feed-forward diffusion transformer framework. A key part is their custom data pipeline, VideoCus Factory, which automatically creates massive amounts of high-quality, multi-subject training data from raw videos. This is why it's so versatile. But the real magic comes from 2 new embedding techniques. First is lottery embedding, which allows the model to compose more subjects in the final video than it was even trained on at one time. Second is temporally aligned embedding, which is the key to making control signals like camera paths, depth maps, and masks work so well by ensuring they're perfectly synchronized with the video frames. When they compare OmniVCus to other top models like Skyreel's A2 or OmniGen, the results are clear. Given the same reference and prompt, the other models often get details wrong. They'll miss a subject or place them incorrectly. OmniVCus consistently gets it right, proving its superior ability to understand and follow complex instructions. Now, for everyone eager to try this, the project page is live with all these amazing demos. However, the code itself is currently listed as coming soon. Given that this is an Adobe research project, you can bet it's going to be a high-end tool when it's released, likely requiring a very powerful GPU. But this is without a doubt one of the most exciting and comprehensive video generation tools we've seen. We'll be keeping a very close eye on this one.
As always, I'll leave a link to their incredible project page in the description below so you can see all of this for yourself. And lastly, we have a tool that dropped like an absolute bombshell in the video generation space, a true underdog story. It's called Pusa, and its creators are making a claim that sounds almost impossible. They've built a video model that they say surpasses the giant WAN 2.1 image-to-video 14 billion parameter model. But here's the kicker. They trained it for just $500. Let's put that claim into perspective because the numbers are staggering. The WAN model they're comparing against is estimated to have a training cost of over $100,000 and uses a dataset of over 10 million samples. Pusa was trained with just 4,000 samples. That's 2,500 times smaller and for a fraction of the cost. Not only that, they claim Pusa is 5 times faster, generating video in just 10 steps compared to WAN's 50. And despite all this, it still manages to eke out a slightly higher score on the V benchmark. While WAN 2.1 is an image-to-video specialist, the Pusa framework is designed to be a multi-talented tool, handling text-to-video, image-to-video, video-to-video, and more, which we'll get into. First, let's look at its image-to-video capabilities. You give it a single frame, and it brings it to life. Check out this prompt. An astronaut riding a horse on the moon amidst moon dust, 1978, shot on Super 8. The result is a grainy, retro-looking video that perfectly captures that vibe. Or this one, a female rock climber on a massive asteroid in deep space. The scale and motion are fantastic. But my favorite has to be this one, an ice cream machine that begins to extrude a fully formed, transparent glass frog. It's surreal, creative, and shows the model's incredible ability to follow a bizarre concept. It also gives you more precise control with a start and end frame mode. You provide the first and last frame of a sequence, and Pusa intelligently animates the information in between. They show this off with the same glass frog example, where it smoothly animates from the start of the extrusion to the fully formed frog. It's also great at video extension. Give it a short 13-frame clip, and it can seamlessly continue the action, extending it into a much longer video. And its text-to-video generations are just as impressive. A simple prompt like "a car changes from golden to white" works perfectly. It handles human motion well, with a person is sitting in a chair and then they suddenly get up and start stretching. And even nails the fine details of realism with "a person is eating a hot dog." But for pure imagination, check this out. A whale with the wings of a bat soaring over the ocean surface under a full moon. The generation is beautiful and perfectly follows the creative prompt. So, with all these features, you have to ask, how did they pull this off on such a tiny budget? The secret is in the name of their technique, vectorized timestamp adoption. Instead of training a massive new model from scratch, they built a clever and highly efficient adapter that works with an existing powerful video model, which in this case is based on WAN's own image-to-video architecture. This lightweight adapter essentially teaches the base model how to handle motion and time progression in a very efficient way. This is why it's so cheap to train and so fast at inference. Now, for everyone who wants to test these claims themselves, you can. In a fantastic move, the team has released everything. The code for Pusa V1, a technical report, and the dataset are all on their GitHub page right now. Looking at the requirements, they don't list a specific VRAM number, but since it's based on a version of the WAN model and designed for efficiency, it's reasonable to assume you could run this on a GPU in the 12 to 16 GB VRAM range, making it far more accessible than the 24 GB plus monsters required for many other models. This is a truly remarkable achievement in efficient AI, and I'll have all the links you need down in the description so you can dive in and try it all for yourself. So there you have it. The tools are getting faster, cheaper, and more powerful every single week. It's an exciting time to be a creator. Which tool blew your mind the most today? Drop a comment below. If you want more weekly AI news just like this, hit subscribe and that notification bell. Stay curious and see you next week.